The Milky Way stretches around us like an endless ocean of light, a galaxy of perhaps 100 to 400 billion stars, each one a sun in its own right, each one surrounded by the possibility of worlds. Over the past 3 decades, we have confirmed thousands of exoplanets, and every year that number climbs higher, revealing hot giants, frozen super-Earths, worlds of water, worlds of metal, and planets that defy our imagination. Statistically, life should be everywhere. Intelligent life should be common. Civilizations, if they emerge even on a small fraction of these worlds, should fill the galaxy with signals, with structure, with evidence of their existence. And yet, the sky is silent. This contradiction, between the overwhelming probability of life and the absolute emptiness we observe, lies at the heart of the Fermi paradox. It is the greatest scientific riddle of our age, a quiet question whispered beneath every telescope on Earth. If the galaxy is so full of stars, where is everybody? Why don't we hear them? Why don't we see their cities glowing on distant worlds, or their starships cutting threads of light between stars? In this silence, there is something haunting, something beautiful, something unsettling. We build detectors to listen for radio pulses, scan the sky for ancient laser beams, search for the faint thermal glow of megastructures, and all we receive in return is the soft background hum of the universe itself. It is as if we are standing on the shore of a vast, dark ocean, calling out into the night and waiting for an answer that never comes. But the silence is not empty. It is a mystery, a doorway, a mirror that reflects our deepest questions about who we are, how rare life might be, and whether humanity stands alone in this grand cosmic arena. Tonight, we explore that silence and the many reasons it might exist. When we look at Earth from space, it appears calm, a blue sphere wrapped in clouds, drifting gently around an ordinary star. But the truth is far less simple. Earth is the result of an extraordinary chain of cosmic coincidences, each one so precise and so fragile that even a small deviation could have left our world barren and silent. Our planet formed at exactly the right distance from the Sun, in the narrow band where water can exist as a liquid, not boiling away or freezing into permanence. It collected enough water to fill oceans, but not so much that it became a water world with no continents, no cycles, no chemistry of complexity. Beneath our feet lies a metal-rich core spinning fast enough to generate a powerful magnetic field, an invisible shield that protects the atmosphere from the sun's deadly radiation. Without it, the Earth would resemble Mars, stripped, dry, and hostile. We orbit our star on a nearly perfect ellipse, with just the right level of stability. Our sun itself is unusually calm. It does not flare violently, does not pulse with instability. And above our sky, the moon stands as a silent guardian. It is far larger relative to its planet than most moons in the galaxy, and because of this it stabilizes Earth's tilt, preventing wild climatic swings that would make long-term evolution nearly impossible. The moon also pulled the tides that shaped early ocean life, stirring the chemistry of our ancient shores. Even the ground we walk on is part of the miracle. Earth has active plate tectonics, a geological breathing system that recycles carbon, regulates temperature, and keeps the planet habitable over billions of years. Most worlds we know do not have this feature. Many are locked in extreme climates, volcanic furnaces, icy spheres, or deserts of crushing pressure. Earth sits in a delicate balance, a combination of temperature, atmosphere, magnetism, water, chemistry, and time, all working together in a harmony that seems almost improbable. This is the heart of the Ray Earth hypothesis, that simple life may emerge in many places, but complex life, creatures, ecosystems, intelligence, requires a perfect symphony of conditions. And perhaps most planets do not have this symphony. Maybe they host vast microbial biospheres hidden beneath ice or thriving in deep oceans, but nothing that builds tools, nothing that looks up at the stars, nothing that leaves signals across the sky. In other words, life might be common, but civilizations may be incredibly rare. Life on Earth began more than 4 billion years ago, rising quietly in ancient oceans long before continents formed or skies turned blue. For most of our planet's history, life was simple, microscopic, fragile, unseen. If we compress Earth's entire timeline into a single calendar year, life appears in March, photosynthesis in July, complex organisms in November. Dinosaurs rise and fall in the final week. And humans? We arrive a few seconds before midnight on December 31st. Intelligence, the kind capable of building technology, sending signals, reshaping a planet, emerged not as an inevitability, but as an astonishing late twist in a very long story. Evolution does not strive for intelligence. It does not aim upward, does not follow a path toward reason or consciousness. Most species survive perfectly well without complex brains, without languages, without the ability to think about the stars. For billions of years, Earth was a world of bacteria, and even after multicellular life exploded, intelligence remained a rare and fragile trait. Out of millions of species that have ever lived, only one developed the kind of cognition that can look beyond its own world and wonder who else might be out there. This raises a profound possibility. Perhaps intelligence is not the rule, but the exception. Perhaps it requires a chain of evolutionary accidents, asteroid impacts, climate shifts, genetic mutations, ecological pressures that align just right, at just the right time. On other planets, life may thrive in oceans, in clouds, in endless forests, but never take the leap toward tools, curiosity, or technology. Entire biospheres could exist as vibrant, complex ecosystems, yet remain forever silent on the cosmic stage. If so, the galaxy might be full of life, swimming, crawling, growing, evolving, but almost completely empty of minds, empty of civilizations, empty of anyone capable of reaching out into the dark and trying to speak. In this vast universe, intelligence may be the rarest element of all. Among all the answers to the cosmic silence, one possibility stands above the rest, unsettling, elegant, and deeply frightening. It is known as the Great Filter, the idea that somewhere along the path from lifeless matter to spacefaring civilization lies a nearly impassable barrier. Somewhere, something stops almost every world from reaching the stars. The universe may not be empty at all. It may simply be filled with countless attempts that never make it far enough for us to detect them. The Great Filter can exist in two places, behind us or ahead of us. If the filter is behind us, it means that the steps Earth has already passed are so rare, so improbable, that almost no other planet manages to achieve them. Perhaps the origin of life itself, that first leap from chemistry to biology, is staggeringly unlikely. Or maybe the real barrier is the jump from simple cells to complex ones, the formation of eukaryotes, an event so unusual it might have happened only once in the entire galaxy. It could be the transition from single-celled life to multicellular creatures, or from simple ecosystems to the rich, unstable, dynamic environments that allow evolution to experiment. If any of these steps are nearly impossible, then humanity stands in a very lonely universe, not because others vanished, but because they never had a chance to arise at all. But the darker scenario is that the Great Filter is ahead of us. In this version, life may be common, intelligence may emerge on many worlds, but something destroys civilizations before they can spread out into the galaxy. The universe stays silent not because no one exists, but because almost everyone falls. A civilization might collapse under the weight of its own technology, its own conflicts, its own environmental mistakes. Wars, pandemics, artificial intelligence misalignment, resource exhaustion, climate catastrophes, or cosmic dangers like asteroid impacts and gamma-ray bursts. Any of these could erase a species just as it becomes capable of broadcasting its presence. This interpretation makes the silence ominous. If we look around and see no ancient empires, no beacons, no monuments of alien engineering, it may not be because we are alone. It may be because civilizations rarely survive long enough to leave their mark. In a universe that has existed for more than 13 billion years, the absence of old, galaxy-spanning super-civilizations could be a warning written in the darkness. They never lived long enough. And that leads to the most profound question. Is the Great Filter behind us, or ahead of us? If it is behind us, then humanity is a miracle, a unique, improbable exception. Our existence would mean we cross the hardest threshold, that the future may be open and full of possibility. But if the filter is still waiting in our path, then humanity may be facing challenges far more dangerous than anything we have overcome. In this interpretation, the silence of the cosmos is not peaceful, it is foreboding. It suggests that every civilization reaches a moment of truth, a moment where it must learn to control the forces it has unleashed or be destroyed by them. The Great Filter forces us to confront the fragility of our world and the responsibility we carry as the only known species capable of contemplating its own survival. Perhaps the universe is quiet because most never reach this stage. And perhaps, standing here on our small blue world, we are approaching that threshold now. There is another possibility behind the silence of the stars, one that is less dramatic than the Great Filter, yet just as sobering. Maybe civilizations simply don't last very long. Perhaps the window between discovering advanced technology and losing control of it is far shorter than we imagine. A species might rise, build machines, unlock energy, reshape its planet, and fade long before it develops the ability to colonize the stars or leave a lasting signature on the galaxy. The reasons for their disappearance may be painfully familiar. A civilization might destroy itself through conflict, turning its greatest inventions into weapons that unleash irreversible devastation. Or it may undermine the very environment that sustains it, exhausting resources, collapsing ecosystems, or triggering climate shifts faster than it can adapt. Energy mistakes could be fatal as well, experimenting with technologies it cannot fully control, or relying on systems so powerful that a single failure becomes catastrophic. Artificial intelligence presents another path to collapse. A species could create entities more capable than itself, but fail to align them with its own survival. What begins as progress may end as replacement. And beyond all self-inflicted risks lie the dangers of the cosmos itself. Asteroid impacts, supervolcanoes, solar flares, gamma-ray bursts, events indifferent to ambition, indifferent to intelligence. If the lifespan of a technological society is measured not in millions of years but in centuries or even decades, then civilizations would rarely overlap. They would flare into existence like sparks in the darkness, bright for a moment, then gone. By the time their signals reach us, their worlds may already be silent. By the time we send an answer, there may be no one left to hear it. In this view, the galaxy is not empty, it is fleeting. A vast stage where countless civilizations appear and vanish, each one too brief to meet another. We may simply be living in a moment between moments, separated not by distance, but by time itself. For more than half a century, our search for extraterrestrial intelligence has centered on one approach: listening for radio waves. SETI, the search for extraterrestrial intelligence, scans the sky for faint pulses, narrowband signals, and unusual patterns that might rise above the noise of the cosmos. It is a noble effort, and a scientifically rigorous one, but it rests on an assumption that other civilizations communicate the way we do, using the same technologies, the same wavelengths, the same logic. There is no guarantee of that. Radio may have been a brief stage in our development, a century-long window in a technological timeline that could stretch for millennia. A more advanced civilization might use laser communication, sending beams of light so tightly focused that they would be invisible unless Earth happened to stand directly in their path. Others might rely on exotic particles like neutrinos, capable of passing through entire planets without being absorbed, creating communication networks we would never detect with our current instruments. And some signals may not be signals at all, but byproducts of alien engineering. The infrared glow of a Dyson swarm harvesting starlight, the unnatural temperature profile of a planet wrapped in artificial structures, the spectral fingerprints of chemicals that do not occur in nature. These are techno-signatures too, but subtle ones, easily mistaken for astrophysical noise or dismissed as measurement errors. There is also a deeper possibility that alien technology operates on principles we do not yet understand. Our physics is young, our engineering primitive by cosmic standards. A civilization millions of years older could use methods of communication that lie far outside our imagination: gravitational modulation, quantum entanglement on massive scales, or techniques that merge biology and computation in ways that produce no detectable radiation at all. If so, we might be surrounded by signals, yet utterly unable to recognize them. It is the cosmic equivalent of fishing in the ocean with a single type of net, designed only to catch fish of one size. If we return with an empty net, it doesn't mean the ocean is empty, only that our tools are limited. The wrong bait, the wrong hooks, the wrong waters. A misunderstanding of what we should even be looking for. In this sense, the silence we hear may not reflect the absence of others, but the narrowness of our methods. We are listening for voices that may not use sound, watching for lights that may not use photons, waiting for signs that may not resemble anything we've ever seen. To find others, we may first need to expand our imagination and our definition of communication itself. There is a possibility more subtle, and in some ways more unsettling, than simple silence. It suggests that extraterrestrial civilizations may exist all around us, not light years away, but woven into the fabric of the galaxy right now, and we simply cannot perceive them. Not because they are absent, but because they are hidden, different, or deliberately avoiding contact. One idea is that advanced species may choose to remain invisible, practicing a kind of cosmic stealth. A civilization capable of manipulating energy, matter, or space itself might easily hide its presence from younger, unpredictable species like ours. They might mask their emissions, bury their signals in natural cosmic noise, or operate using communication channels completely undetectable by human instruments. Not out of malice, but out of caution, the way we dim lights in a wildlife reserve so as not to disturb the creatures living there. Another possibility is even more profound. Alien life may not resemble us at all. We search for biology that mirrors Earth's patterns, carbon-based, water-dependent, operating at temperatures comfortable for terrestrial cells. But intelligence could emerge in forms beyond our imagination. It might exist in subsurface oceans beneath icy crusts, in biochemical systems radically different from DNA, or in networks of neural-like organisms that grow through forests, deserts, or hydrothermal vents. We might stand beside life and not recognize it as life. And it could be even stranger. Consciousness may arise in environments we consider hostile or impossible. The upper atmospheres of gas giants, where floating organisms drift in storms the size of continents, or in plasmas near stars, where magnetic and electrical interactions become complex enough to support patterns analogous to thought. There could be intelligences that exist on geological or stellar timescales, thinking in rhythms far slower or faster than ours, making communication impossible without shared perception. Then there is the zoo hypothesis, the idea that Earth might be part of a protected region, a cosmic nature reserve, observed from a distance but left untouched. Older civilizations may choose non-interference, allowing young species to evolve without influence, out of ethical principle or scientific curiosity. From this perspective, our isolation is intentional. We are being watched, but not contacted. In all these scenarios, the universe may be alive with intelligence, yet completely opaque to us. We may be surrounded by civilizations older, smarter, or stranger than we can imagine, but our senses, our technology, and perhaps even our minds are not yet capable of seeing them. The silence, in this view, is not emptiness, it is a curtain we have not learned to lift. Even if intelligent civilizations exist, and even if they are trying to communicate, the sheer scale of the universe creates a barrier more absolute than any language: distance. The speed of light, the fastest speed allowed by the laws of physics, is impossibly slow when stretched across the Milky Way. Light takes 8 minutes to reach us from the Sun, 4 years from the nearest star, and more than 100,000 years to cross our galaxy. If someone on the opposite side of the Milky Way sent a message today, humanity might still be in its infancy by the time it arrived. We could answer, but the reply would not return until long after our civilization has changed, vanished, or evolved into something unrecognizable. In this sense, the cosmos is not silent, it is simply too big for real-time dialogue. Interstellar communication becomes a series of messages drifting through darkness for millennia, like bottles cast into an endless ocean. Two civilizations might exchange only a handful of sentences before one or both disappear. Entire cultures could rise, fall, and be forgotten before their words even reach another shore. This gives rise to a haunting idea, a galactic delayed network, a vast, ancient web of messages traveling slowly between stars, never synchronized, always out of time. A civilization might detect a signal from a world that no longer exists, or send a reply to a species that has already gone extinct. Communication becomes archaeology. Listening becomes a form of reading history. The galaxy may be filled with these drifting echoes, fragments of thoughts and greetings from civilizations separated not by space, but by centuries and epochs. If this is true, then silence does not mean loneliness. It means delay. It means that in the great temporal architecture of the universe, our voices are still too young, too faint, too newly born. We are speaking into a cathedral so enormous that even our loudest cry has not yet reached the nearest walls. The cosmos may not be unwilling to answer. It may simply be answering very, very slowly, on a timescale far larger than the span of human existence. If radio waves and laser pulses are only the first, primitive tools of a young species like ours, then the true signs of advanced civilizations may lie in something far grander, technosignatures written into the fabric of their worlds, their stars, and even their galaxies. These clues would not rely on intentional communication. Instead, they would be the byproducts of engineering on a scale we can hardly imagine. One of the most famous ideas is the Dyson sphere, or more realistically, a Dyson swarm, a vast constellation of solar collectors orbiting a star, harvesting nearly all of its energy. A structure like this would block visible light and re-emit enormous amounts of heat in the infrared spectrum. To a distant observer, the star would appear strangely dim and unusually warm, glowing faintly like an ember wrapped in shadow. We have already begun to search for such signatures, scanning the sky for stars that do not shine the way nature intends. Another technosignature could be artificial light on a planet's night side. As telescopes grow more powerful, we may one day detect city-like illumination, the unmistakable glow of technology lighting up continents or coastlines. Natural processes cannot produce such patterns, ordered grids, sharp boundaries, repeating structures across the dark hemisphere of a world. If we ever see a planet whose nights sparkle with structured radiance, it would be one of the clearest signs that we are not alone. Atmospheres may also betray their builders. A planet wrapped in gases that cannot be explained by geology or biology, industrial chemicals, engineered compounds, or exotic molecules that form only in artificial environments, could reveal the presence of technology long before we see the civilization itself. The wrong chemistry in the right place becomes a beacon. And then there are megastructures, rings around planets, artificial moons, orbital habitats, star shades, or colossal mirrors designed to harvest energy or reshape a world's climate. Even if these structures are too small to resolve directly, their gravitational or optical effects could be visible across light years. All of these leave behind infrared heat signatures, the technological footprints of civilizations that convert energy on massive scales. Heat is the universal byproduct of advanced activity, impossible to avoid and extremely difficult to hide. A civilization that expands across its solar system, or beyond, will inevitably leave a thermal trail. If radio waves are the whispers of young species, these technosignatures are the deep footprints of the ancient ones, civilizations that have mastered their worlds, their stars, and perhaps their place in the galaxy. To find them, we may not have to listen. We may simply have to look. In the end, the silence of the universe may not be a verdict, only a reflection of our own limitations. Perhaps the cosmos is not quiet because no one else exists, but because we have not yet learned how to listen. Our instruments are young, our understanding narrow, our imagination still growing. We may be standing in a symphony too vast for our ears, hearing only the faintest whisper of a song that has played for billions of years. Or perhaps the truth is more extraordinary. Maybe we are the first, the very beginning of consciousness in this corner of the galaxy, the pioneers of thought in a universe that is only now awakening to its own reflection. If so, our responsibility is enormous. We carry the first spark, the first question, the first attempt at reaching beyond a single world. And there is another possibility, equally profound. Maybe we are not the first, but the last. Maybe countless civilizations have risen and fallen before us, leaving only fading echoes in the dark, their voices gone long before ours arrived. In that scenario, we would be inheriting a quiet stage, stepping into a silence left behind by those who could not endure. Whichever truth awaits us, the silence is not empty. It is a mirror, a vast, cosmic reflection that forces us to examine who we are, what we value, and how we will shape our future. As we search for others, we discover our own vulnerabilities, our own dreams, our own fragile place in the grand expanse. And perhaps this is the quiet lesson written in the darkness, that by reaching out to the stars, we are, in the deepest sense, reaching inward, learning not just about alien worlds, but about ourselves.